Hello, Math 1. So this lesson's on 1012, which is how do we use these regression models in real-world applications. So when I break this down and look at it, the first part says the table shows the U.S. daily production Y X years after 1990. Okay, so here they show you in your table. So 0 would be equivalent to like 1990. 1 would be equivalent to 1991. And if you look at the Y values, those are the barrels of oil produced in those years. So now what I've done is I've taken this data, right, and I entered it into a Google Sheet like such, right? Now I'm going to copy that data, and I'm going to go over to Desmos, and I'm going to paste it in there. And as you can see, we see a correlation of these, all of this data. And we notice that it happens to be a linear correlation. And if we were to draw a best fit line, we know it would be negative, a negative slope. So we would say that this data has a negative linear correlation. Okay. Now, there is a typo here. It says describe the correlation between the price of houses, but it should be the production of oil based on the years after 1990. And what we could say here is we can say each year, what do we notice about the production of oil? Does it go up or down? The production of oil decreases, right? So when I look here, we could say each year the production of oil decreases. Now, what we're going to do is we're going to use Desmos to find the model that best fits the data. So I'm going to go right to Desmos, and I'm going to go in here and I'm going to do what I did yesterday, y1 tilde mx1 plus b to get the line of best fit here. And if you notice, the line of best fit would be about negative 129.833 x plus 6701.56. So when I go back here, I'm going to take that and write my equation. So the regression model, y equals negative 129.833 x plus 6,700, what was it? 6,701.56. So that is the model. If I look here, that is the line that best fits the data, comes closest to all of the points. Now, with that in mind, right, use your equation to predict the oil production in 2005. Now, if I wanted to do this, I'm going to just use this equation I came up with. So I'm going to say y equals in 2005, right? If year 0 is 1990, 2005, I'm going to say x is 15 years after that, so x equals 15. So negative 129.833 times 15 plus $6,701 or 1.56. So I pull out my calculator, negative 129.333 or 833 times 15 plus 6,701.56. That would give me, in 2005, it would be 4,074.065. Okay, that's how we would use that model. Okay, now in the next one, it says the following table shows the number of houses sold at each price range. Create a scatter plot for the data. So again, I'm going to go to Google Sheets and enter that data. So as you can see, I entered this data. Now, when you look at your X values, remember, X values are your price. The Y values is the sales of homes. Okay, so now I'm going to go to Desmos. no different than what I've done before. I'm going to paste this scatter plot in there. I notice that this is a linear regression model again, and it tends to have a negative relationship. So when I go here, create a scatter plot, determine if it's linear or exponential. Same as the one up above, it's going to have a negative linear correlation. Then describe the correlation between the price of the house and the number of houses sold. Well, as I look at it, as the price of the house goes up, what happens to the sales of the homes? It goes down. So as the price of the home goes up, the number of houses sold goes down. Now, we want to find the regression model that best fits this data. So I'm going to come over here. It's linear, so y1 tilde mx1 plus b. And if I look, the regression model would be negative 0.79 x plus 249. So as I write this down, my regression model was y equals negative 0.792857x plus 249.857. If I wanted to predict what this model or what the number of houses sold would be at 215,000, right? What I can say is x would be 215. So I'm going to take y equals negative 0.792857 multiplied by 215, add the 249.857. So I plug that in the calculator, negative 0.792857 times 215 plus 249.857 gives you 79.39 houses. So about 79 houses. And if I look, 215 would be right between there. And doesn't that seem like it'd be right around 79 houses? It would. Okay, so we can use this data to predict the number of houses sold. So the next one, right? So when we go to example 3, the accompanying table shows the amount of water vapor, Y, that will saturate 1 cubic meter of air at different temperatures, X. So what we're going to do is we're going to go ahead and create a Google Sheet for this and then put it in Desmos. So as you can see, I typed this data in. I'm going to go ahead, I'm going to copy the data. I'm going to copy it, go to Desmos, and I'm going to paste that in. And as you can see, this data, right, tends to have an exponential growth model to it. Okay, so now when I go to look at this, I know right away this has an exponential growth correlation. All right. Now, if we describe this, it should be the air temperature to the water vapor. You know, as the temperature increases, the water vapor increases. Okay. Sorry for the typos here. So we want to find the regression model that best fits it. Since we look at this and we see that it's exponential, that's the growth model we're going to use. Y1 equals A times B to the X1 power. And if you look at this, oops, what happened to our table? So once you see that you have your table here and you notice these points tend to model exponential growth, once we write that linear regression model, this is what we get. And our model here is going to be your A value is 5.26515, your B value is 1.05. So we're going to write that down and we're going to say the regression model that best fits it is going to be y equals 5.26515 times 1.05804 to the x power. So they want us to predict what the temperature would be at around 50 degrees Celsius. Well, all I'm going to do here, for this one, I can plug that x value in. I can let x equal 50 and plug that in. Or I could take the value of a and b, plug the function in here, and if I go up here and I click on table, now in that table, another thing I could do is for my x value, just type in 50, and the y value would be what I'm looking for. So another benefit of using decimals is to figure this out. And I would say, right, at 50 degrees Celsius, it would be about 88.4. It would be approximately 88.4. Okay, so the last problem here. The accompanying table shows the average salary of baseball players since 1980. So they want us to create a scatter plot and determine if it's linear or exponential. So I'm going to go ahead and type that into Google. So as you can see, I typed in the table here. And once I type in that table and I go to Desmos and I plot it, this is what our model becomes, right? That there tends to be more exponential growth than it is linear. So in here, we're going to say that it had a exponential growth correlation. And we'll say as the years increased, the salaries increased, right? Now the regression model that fits it, since it's exponential growth, I know I'm going to come down here, y1 tilde a times b to the x1. And if I look at that, that would be exponential growth. And here's my model, right? So I'm going to go ahead and I'm going to transfer that to my paper. Y equals 264.041 times 1.21641 to the x power. And right away, if I wanted to figure out the salaries in 2010 and 2025, for 2010, if that's after 1980, that would be 30 years after, so I'm going to let x equal 30. For 2025, I'm going to let x equal 45. Okay, so now what I like to do is type this equation into, right, Desmos, and I'm going to say y equals 264.041 times 1.21641 all to the x power. And if I go in here and I go to my table, now in my x value, to find 2010, I would go 30, and that would be 94,204. 94,204. And if I were to look at 45, right, you get a really big number also. So in this case, it says 1.99, right? But that's obviously going to be a lot bigger. But it would be oops, sorry. That would be, in this case, 1,779,388 times 10 to the 6th, which if we move that decimal over 6 places, it'd be 1, 2, 3, 4, 5, 6. It'd be 1779388. So it would be 1,779,388. Okay, so this is how we use the regression models in real life. Go ahead, try the homework, and let me know if you have any questions.